Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and welcome to today's webinar about getting control of your cloud infrastructure and upgrades with MCP DriveTrain and also lifecycle management. Let me introduce you to today's speaker. Today's speaker is Ryan Day. He is our field CTO of platform here at Mirantis, and he is all about technical leadership in product and field operations. He's done a lot of advising of customers on how to build and operate the best cloud infrastructure, so he really knows what he's talking about. Before we move on to the actual webinar itself, let's do a little bit of housekeeping. Okay, if we can go to the next slide, Ryan. Thank you. You will notice that there is a window somewhat like the one that you see on this screen. If you have any questions, please go ahead and submit them in this pane. We will collect them and answer them at the end. Let me go ahead and answer the most common question that we often get is, are we going to provide the slides at the end? Yes, we will provide the slides at the end, but that's no excuse for not paying attention, because we are also going to have a demo that will not be part of the slides. It will be part of the video, but not part of the slides. So you will want to pay attention for this. It is cool. So without further ado, I'm going to hand off to Ryan, who will give us an idea of what we're going to talk about today. Ryan, good morning.
Good morning. Thanks, Nick. So as far as agenda goes, this is kind of the outline we have today. First, we're going to go over some context of what we're going to talk about today in more depth than I could put in a single agenda slide, as well as a little bit of an overview of what Mirantis MCP is and how that fits into both the other topics and the demo itself. We're going to define some terms. In particular, we're going to define a little bit about what continuous deployment means, explain a little bit about what DriveTrain is in the context of MCP, and then go over how DriveTrain gets used. Summarize that and then jump into a demo. I will go ahead and take this as an opportunity to let everyone know that today's demo will not be live. It will actually be a recorded demo that I will speak to. The reason for that is actually that we had a power issue in our lab in Sunnyvale, and I'm unable to do the demo live as a result. So yeah, at the end, we'll do Q&A, and as we go through this, please feel free to put your questions into the GoToWebinar control panel, and Nick will make sure I get those answered either as we go along or at the end. All right, so let's start off with that context we were talking about. This is really, talking about why we would want to upgrade OpenStack. There's some statistics in here that aren't necessarily related to that, but it's pretty much that you would want to upgrade to Ocata for specific features that would be either introduced to OpenStack, either in Mitaka, either in Newton or Ocata. Mirantis is, as far as our release of OpenStack versions, we have jumped from Mitaka to Ocata, so that's a 2-release jump, and that's the demo that we're going to show today is actually going from Mitaka to Ocata. So we'll go over that. The way that we're going to be doing that is through a Jenkins pipeline where we've automated that upgrade process. So let's talk a little bit about what an OpenStack upgrade actually is and what it requires. So really what it is you're upgrading packages. You may very likely need to update config files as options and primitives have changed between releases, especially if we're jumping 2 releases. And you'll need to sync the database schemas for each OpenStack service. So again, what we're targeting is a release to Ocata from Mitaka through 2 releases. We're going to do that generally in 2 phases. The first phase is going to be the control plane upgrade, and the second phase is going to be upgrading the compute or gateway node agents, meaning like network nodes for Neutron. Generally, we stage it that way for a specific reason, and that is because we can actually upgrade the compute and network gateway nodes independently of the control plane. So we can continue to use, for example, Mitaka-based compute node agents against a control plane running Ocata. So that allows us to kind of stage the upgrade process and maintain data plane uptime during the control plane upgrade, meaning that when we do the demo today, the instances and the users that would have had workloads running in the cloud that we're upgrading would not have been disrupted. And again, we'll be using a pipeline to do that upgrade. So a couple data points in terms of what this looks like in terms of time. So we're going to actually show kind of three different things. One is a preparation and validation step, which includes a few things that I'll go over in more detail later, but basically we're going to do some validation against the database schema changes and the API changes before we have to actually even start the upgrade. We're obviously not going to sit here for 40 minutes to watch that, but we'll kind of fast forward through it and show the result. Then we'll do the actual upgrade of the control plane. Generally, that takes about 42 minutes in the lab environment that we've been doing it in. It incurs no downtime on the actual data plane running in the cloud, meaning that network traffic is still flowing, instances are still running, all that good stuff. Generally, the approach after that is going to be to do a cascade or batch upgrade of compute nodes following the Ocata control plane upgrade to get those compute nodes upgraded as well. That's generally going to be scheduled out after the control plane upgrade and would be something that you're going to want a degree of control and scheduling around when you're doing that, as compute nodes may or may not be impacted depending on a number of things that I'll go over again a little bit later. And then lastly, we need a rollback process, an automated rollback process. So that's actually part of the same pipeline that I'll go over in a little bit as well. All right, so more context. Let's talk about a little bit about what Mirantis Cloud Platform is. This is the highest level kind of block diagram that I could show about what MCP is, and it really is taking a whole lot of open source components and building out of it kind of three categories or at least three complex systems. One of those complex systems could be OpenStack or Kubernetes or the amalgamation of all the SDN and SDS layers that go along with that. Basically your open cloud platform or open cloud software. And then alongside those are going to be the systems of responsible for lifecycle management and continuous deployment, and that's DriveTrain, or an operations support system by way of Stacklight. So broken out, this looks roughly like this in terms of what these components are actually doing and what their functions are. And we're really going to focus today on the left side, DriveTrain, because DriveTrain is what's going to actually be executing this upgrade during the demo. DriveTrain consists of a number of components here that you'll see. We need something to handle version control. We need something to handle a code review process with automated feedback from testing. And we need a mechanism for actually triggering the continuous deployment, triggering the deployment. And then we need a place to store artifacts. Artifacts can be things like Debian packages or Docker images or anything like that. So packages and Docker images are the most common of those. Then we need a way to actually classify all of the parameters that we're feeding into these complex systems that we're building, and we need a way to perform execution logic against those. And I'm going to go over in detail what the components are for each one of those kind of functional categories within DriveTrain. But this is really kind of a little bit, I would call it a 10,000-foot view of what MCP is and what capabilities it's providing. As with any kind of enterprise software, we need to have some high availability, and this is kind of just a visualization of how we're striping every service that we deploy basically across three physical nodes. So, you know, we'll be load balancing across them. Our messaging bus gets striped across file systems, you know, a distributed shared file system, database, and again, for other components, there's going to be similar things. So what does continuous deployment mean? In short, continuous delivery, which is kind of a moniker around both continuous integration and deployment, is a software engineering approach where teams are producing software in much shorter cycles, and that helps to actually ensure that the software can be reliably released at any given time. But it's important that that's actually a reality. Producing software in short cycles isn't necessarily enough to ensure that you can deploy it or release it reliably. There's a bit more of a process behind that. And that's kind of what the second sentence is alluding to, is that there needs to be really a straightforward and repeatable deployment process in order for continuous delivery to be reality. So why are those frequent releases a good thing? Well, it enables software to be deployed at any time, which means that you can introduce things like automated testing and into a release cycle a little bit easier. You can keep the delta or difference between a development staging and production environment pretty minimal, and that actually helps you to identify problems and resolve them faster, as the amount of change is less. There's less sprawl in the delta there, and then obviously new features are more rapidly available. The last point I'll make, and that's kind of what this little graphic at the bottom is trying to get across, is that generally with lifecycle management of an enterprise application or an infrastructure platform, there's going to be a number of processes involved. There's going to be somebody that's going to write the software or vet the software, do a POC, whatever it is, and come up with an architecture, and then that needs to be tested. And there's going to be, often a different group responsible for that, using different tooling. Potentially, there's like a handoff between each stage of this process, and then acceptance of those tests, that testing, and then deployment, and then ultimately maintenance. And there's more than 4 processes involved. But what we really want to do with continuous deployment is reduce that to really one process used by all. So I'll actually show a diagram of what that looks like here in the next section. But now let me talk about why any of this matters. Why does any of it matter? We've just been talking about technology and deployment and automation and all this stuff. What does that actually translate to in terms of business value? And to me, I think that needs to translate into one of 3 categories, and each category has a duality to it. So it either needs to save time or accelerate time to market. It needs to either reduce cost or increase revenue by introducing new services or whatever that needs to look like. It needs to reduce the amount of human effort involved with operations or deployment, or it needs to enable people to be more productive in those systems. So this is the vein or the lens through which I try to look at everything to do with MCP and try to tie that back. So keep this kind of representation of 3 categories in mind, because when I get to the summary, I'm kind of going to touch on this again. All right, so let's talk about DriveTrain. I mentioned a whole lot of open source components being involved earlier. This is just a splash page these are some of the open source projects or software that we're using inside of our greater MCP product to deliver basically Kubernetes and OpenStack as cloud platforms. Again, we categorize those in these three kind of pillars, and what DriveTrain is actually allowing us to do across all of those components is to provide an on-premises or an on-premises pipeline to consume and deploy all of those technologies glued together into cohesive, complete complex systems like OpenStack, like Kubernetes, like Stacklight itself and DriveTrain itself, and like other things as we mature this kind of prescriptive DevOps toolchain. Having things like version control of the actual cloud configuration and separation from the actual software itself, having the configuration stored separately from the software itself, not at runtime, but at least have a central place where that configuration is stored. Obviously, during runtime, that configuration is stored with the software, but there should be a source of truth for that configuration outside. We also need a mechanism through which we can validate any change or upgrade or update through a staging environment prior to putting it in production, and we need that to be very automated. So again, toward the last bullet, having an automated, repeatable process and incurring little or no downtime is kind of critical. So what are we doing with DriveTrain? We're basically continuously releasing technology. We're releasing features on basically a couple-week cadence, like a 2-week cadence rather than a biannual cadence. We're introducing updates and fixes much faster, providing the capability for automated in-service upgrades for major components, and just generally providing the means through which an operator can continuously deploy a cloud infrastructure and applications for that matter. So more on those same kind of points that I'm making. We subscribe to kind of a model-driven architecture, and when I was talking about configuration being centrally stored earlier, that's the model-driven architecture is basically the kind of schema or the logic of how we've carved that up and made it human readable and intuitive. And the way that we've done that is we've done a few things around separation of services from components and systems. We use declarative methods and templating with class hierarchies and dynamic binding to make this metadata model that is the definition of state for your cloud infrastructure meaningful and intuitive. Next, we're actually using CI/CD methodologies with Jenkins and Groovy-based pipelines, Groovy script pipelines for consuming that, right? So it's great that we're publishing new things. How do you actually deploy it? And the mechanism that you do that should be an automated process through a tool like Jenkins, with automated ways to actually deploy across both staging and test environments and production. The last thing I want to mention about this is that this tool chain that we built in DriveTrain, there's nothing specifically targeting, or there's nothing about the components in this tool chain that are specific to OpenStack or Kubernetes or infrastructure. They're really tools that are leveraged very widely in the cloud context by application operators to perform continuous deployment of those applications. So with this tool chain, we can and do deploy things like platform as a service, container as a service, serverless compute frameworks, and actually just workloads related to analytics and media and network function virtualization and a wide array of those. So let's get into those components. Been kind of alluding to them for a while. From the perspective of version control, we are storing all configuration metadata in Git. There's a code review process in front of that facilitated by Garrett. Jenkins is basically the server automation component that's doing continuous integration and deployment. It's responsible for kicking off jobs, and basically we're using it as a little bit of a high-level orchestrator over a config management system. And then we have a place to store all the artifacts, right? Like we can use Aptly and Docker registry for kind of consume-oriented storing of those artifacts and control of what gets pushed out. But in some cases, our customers and partners actually want to get from us source code and maybe make modifications and integrate their changes or their software with ours. And in those cases, we often recommend JFrog Artifactory as a more complex artifact repository system or artifact management system. Salt is the config management engine that we're using for deployment. Basically, it's responsible for the low-level execution logic of things like managing configuration of components, deploying packages, restarting services, those kinds of things. And we're extending that through something called reclass. Reclass, its moniker actually comes from the first 3 words you see in its description. It's a recursive, it's actually a recursive external node classifier. And what it's responsible for doing is giving us the concept of classes within the metadata that we use with Salt. So the concept of basically creating a hierarchy of inherited classes, and reclass is responsible for recursing through that tree of metadata and coming up with what the what the end result or salt pillar data should actually look like. So it's also doing one other thing, and it's dynamically generating node configurations so that we don't actually have to maintain any declarative definition for a specific node. We maintain that for kind of holistically in the metadata model, and then the individual node configuration is generated by reclass. Okay, so how do we put that into practice? Let's touch back on that model-driven architecture again. You'll notice I'll spend a bit of time on this because it's pretty core to how we have built our product. Really, our goal here was to separate each individual service. You remember that logo slide I had up there with all those open source components. The goal that we had was to find a way to orchestrate all of those components, but still maintain reusability. Right? We wanted to build these complex systems like OpenStack, but we wanted to maintain reusability of the service orchestration components for each one of those pieces of software. So the way that we've split this up is that our SALT formulas, which contain both the service level metadata, which is completely agnostic to the more complex system, as well as the execution logic for the things that I mentioned earlier, like managing files, and configuration and package deployment, services being restarted, whatever it is. Keeping that completely separate allows us to maintain reusability for every single component that we build a SALT formula for. Next, we have the system level of metadata, and that's basically a common product repository for us. So every customer is running pretty much the same system level metadata. We don't maintain forks of it or branches of it for specific customers. And really what it's defining is reference architecture of complex systems in a consumable way, meaning that there's going to be class definitions in the system level of metadata that we may not use in your deployment. But you have the option, and actually new features as they're released will be exposed through that system level of metadata so that you can consume them simply by calling a class. It also minimizes the amount of metadata that has to be exposed and manipulated to do a deployment. So that brings us to the cluster level of metadata, where we are defining deployment-specific metadata at the very least. So this needs to include things like potentially secrets, potentially, definitely IP addresses, host naming conventions, things like that. But also, you may have specific things that you want to implement that are going to be different from what's defined at either the system or service level of metadata, and cluster metadata always takes precedent. The way that reclass is configured in MCP, cluster level of metadata always takes precedent. So if for some reason I ever want to override what's defined at either the service level or the system level, I simply define that same data structure with new values in my key value pairs. So this whole idea of a metadata model, by the way, is essentially just a huge map or a huge collection of key value pairs that have a data structure involved. I can actually show a visual of that a little bit later if there's interest as well. But that pretty much covers the high level of how we've gone about implementing a model-driven architecture in MCP. Please feel free to ask questions on this particular subject. I like to kind of dive into this with people and help them get an understanding for how we've done this. Okay, so in real, it's great that we now have a little bit of a concept around what our model-driven architecture looks like. What is the actual operator doing when he's interacting with MCP DriveTrain? This is a visual that represents that single process that I mentioned earlier, whereby people are making configuration changes, updating packages, basically performing the upgrade. This is the same process through which a OpenStack upgrade would be triggered. So Mirantis is providing test frameworks, packages, configurations, artifacts, features, whatever, new systems even. And those get consumed and potentially modified by the operator and checked into version control. Right, when you first get this stuff, it's always going to be basically in a Git repository, and then you're going to create your changes and push it to that same Garrett environment, and then manage it that way. So configuration is stored in Git. Artifacts are basically pulled by the individual nodes in the cluster. But the process is basically user pushes configuration to Garrett. Automated testing should be triggered where Jenkins is deploying a change out to either some virtual lab somewhere or a staging environment or test environment, and then reporting back a result. And then another user is basically not the person that committed it generally, but another user is reviewing that code change, the result of the testing, and saying, you know, +1, let's go ahead and introduce this to production and bless this as a change that can go forward. Generally, we don't actually automate the pipeline triggering for a production environment. We want that to be to have some oversight by a human. So then the user or the operator is going to log into Jenkins, trigger that pipeline, and those changes will get rolled out to the production system through Salt as the configuration management and execution, which is responsible for the execution logic across the nodes. And then the last part of this visual is actually at the top right, DevOps portal. I didn't mention this earlier, but part of the Stacklight umbrella or column that I mentioned earlier has basically a single pane of glass for all of the dashboards across, you know, DriveTrain and Stacklight and potentially the cloud platforms themselves, to have a single pane of glass where all of those are nested and can be visualized in a central place. All right, so here's actually a screenshot showing just that. This is actually DevOps portal showing DriveTrain's you know, pipeline catalog, and this is where you would go to actually click and run through one of these pipelines. You could also go directly to you can actually see on the left side the Jenkins dashboard. That's actually just a straight up Jenkins dashboard that it would pass you through, and you can interact with Jenkins natively there. Okay, so we're 28 minutes in. I got to speed this up a little bit. I already feel like I'm talking quickly, but in summary, remember that business value slide that I had earlier about all this technology needing to feed one of these three categories. And my postulation is that DriveTrain in particular, the one constant value of DriveTrain is that it should save time. You know, through this tool chain and subjectively through its consumption, you may or may not impact human resources. You may or may not impact time to market and time to release your software. But the one constant across all three of these categories is pretty much that you should save time. So that brings us to the demo. I don't see any questions yet, so I'm assuming they're being held until the end. So I'm going to jump over to. Yeah, Nick, did you have something there?
No, I was just going to say that we're holding the questions till the end.
Okay, fair enough. Fair enough. Okay, so introducing us, or to introduce kind of this upgrade real quick, I'm going to go through a few more slides. Just going over what we're actually going to show. So at a high level, this is the same slide we had in the other deck. We are upgrading packages, updating configuration files, and doing a database schema synchronization for each one of the OpenStack components that's deployed. We are going from Mitaka to Newton, so we're going through 2 major releases. And today what we're actually going to demo is just going to be the control plane upgrade. This is not going to include compute node and network node upgrades, as those can be generally scheduled out as a second step. We do have pipelines for those that you can see in the DriveTrain dashboard that I showed earlier. Okay, so moving forward, actually So moving forward, the first step is actually going to be to change the metadata model to give it the definitions that are needed for it to trigger an upgrade. So that can also include things like, you know, release-specific metadata classes. So in this case, there's going to be things around glare for glance, the Nova placement API, new Keystone endpoints, obviously for that new API, and then a Nova cell database. And then also you're going to want to include classes for backup and restore of the database if you haven't already. Generally, in a production system, you're already going to have those classes included because you're going to want your stateful databases that are part of these systems to be backed up and restorable in an automated way. So the second portion is going to be actually doing a verification of that database sync that I keep mentioning, and that the APIs are functional after an upgrade. And the way that we're going to do that is we're going to create a new virtual machine to act as a single node OpenStack control plane. We're going to create a new database there and a Galera cluster sitting on that, single node Galera cluster sitting on that. And then we're going to dump the production databases and restore them into that test database. After that, the services will be brought back online, or be brought online on this test VM, and we'll verify that the APIs are still working and that the schema changes were performed appropriately. So this is kind of our verification step. This does not replace a staging environment. I just want to be clear about that. This is just a simple verification of functionality and that the database schema update actually goes smoothly. Okay, so then step 3, or phase 3 of this, is going to be performing the actual upgrade. So that includes rebuilding the virtualized control plane nodes with Ocata. The reason that that's necessary is that we're actually going from Ubuntu Trusty to Ubuntu Zenile for these control plane nodes and proxy nodes. Then we're going to redeploy those, basically reconfigure those with Ocata. So we're going to go deploy all the packages for Ocata on those nodes, configure them exactly in accordance with our metadata model, and then lastly, verify that services are working correctly. And that's actually done as part of the Jenkins pipeline as well. And the last part is actually optional. So we mentioned rollback earlier. We have the ability to just automate the rollback process and basically revert everything back to the way that it was when we started. That means that we're changing the database, the source database in the reclass model, restoring, actually there's a typo there, should be a CTL, not CLT, but control nodes and proxy nodes get restored to their original disks, and we're restoring the previous database schemas, and then verifying services are working correctly. This actually goes pretty quick. It takes like 8 or 9 minutes in our environment to do a rollback. But yeah, so one last comment is that because of the way that we're choosing to do this upgrade in this scenario, so the control plane upgrade, we don't have enough headroom in this lab environment that we're doing this demo on in order to have 2 parallel control planes at once. And that means that we're taking down the Mitaka-based control plane temporarily while we build the Ocata-based control plane. One option here would be that if we do have headroom for that, we could run both control planes in parallel and simply to basically shorten the amount of downtime on the control plane portion. So, in this instance, we probably have somewhere between 30 and 40 minutes of control plane downtime because we're replacing essentially a Mitaka control plane with an Ocata control plane with the exact same configuration and database information. But if we could do both in parallel, it would reduce that downtime to basically just the time it takes to disable the services, do a database sync, backup, dump the database, and restore that database on the other side and do a database sync.
And Ryan,
just
to be clear, that even in the situation where we take down the control plane, the workloads themselves are unaffected, right?
Yes, exactly. So
usually,
yeah, the data plane. Yeah. The data plane, the instances that are running, the networks that are passing traffic, the storage volumes that are being used, none of that's disrupted by this. This is simply the control plane aspects of OpenStack are being upgraded. And there's about in this demo, there's about a 40-minute outage of that control plane, meaning people can't create new OpenStack objects. They can't navigate to Horizon and start creating new instances. Okay, and then lastly, the compute and upgrade node process is generally going to be in place. It's an upgrade of packages and configuration files and a service restart. Generally, it should be done in batches or sequentially somehow. It depends on basically the workload's tolerance for failure and kind of how you want to do that. Generally, we come up with a pretty simple but just prescriptive plan on how this should be done, kind of on a per customer and per workload basis. But again, workload should be untouched. In the case of OpenContrail, we have seen that during a kernel reload, there's about a 3-second data plane downtime incurred in that case. All right. So let's jump into the actual demo. So this is the Jenkins dashboard that we're looking at here. Start this. Okay, there we go. Hopefully everybody can see this okay. These are kind of at the top here. You can actually see the stages of this pipeline. So when we go ahead and navigate over to the salt master, we're going to actually make a modification to the metadata. Here we're listing all of the nodes, the logical nodes that are connected to the salt master that can be managed by it. You know, here's a list of those. You can see proxy nodes and CTL nodes. We're going to log into a controller node and take a look at the running instances that are in this cloud. So we can see that there's 3 instances running. We can see that the API version is going to be 13.1.2, which is Mitaka. And then we're going to look at the KVM, basically the foundation or the infrastructure nodes where all those virtual machines are running, the virtual control plane nodes. And this is a list of the ones that are running here. Here we're going to log into the actual the nodes hosting our database, our MySQL database, and log into that and show a list of databases real quick. So we can see all of our OpenStack service databases are here. And after this, we're gonna jump back over to Jenkins, and we're going to go ahead and rebuild this pipeline. Okay, so here we have some inputs. We have credentials for the salt master, the API endpoint, and then we have these flags that we can set. These are what we were talking about earlier. Perform the actual upgrade to the live system, do a rollback, and whether or not we want to run that verification test as a step in the pipeline. So these are all toggleable here. We can run all of them at once, or we can just check one at a time and run different jobs for each. Here we're going to go ahead and check all 3 and run those all as the same job. Next, we can, while this is running, we can actually take a look at the console output, which shows us some pretty interesting information. We see it starting the testing pipeline. Starting the testing pipeline here. And right now, Salt is actually going out and doing some preparation, but then it's going to go ahead and start a new virtual machine called UPG01 on one of the KVM nodes, one of the infrastructure nodes. It's going to start this virtual machine where we're going to perform this verification step. So let's take a look at the host where this virtual machine is going to be created. Same one that we were just looking at a minute ago, KVM02. We actually saw that in the Jenkins console output, but that's where it's being placed. And we're going to do a verse list. Yeah, so we don't see it yet. It's still being created. Let's give it another minute here. Okay, so now it's been created. So now we see it. UPG01, that's going to be our verification machine that we're going to use to verify the database schema changes and API functionality prior to upgrading the target environment. So what's happening now is it's actually going to be bootstrapping the virtual machine. So once we've deployed it with an image, but now we actually need to go deploy OpenStack on it. And we'll see that kick in here in a second on the console output. Let's wait for that to show. Okay, so now we see it's bootstrapping and deploying OpenStack. Right now it's actually deploying. Oh, it's creating a backup right now, sorry. So it's creating a backup on the live database right now, and it will move that backup over to UPG-01. Up there, you just actually scrolled by, but it showed one of the database nodes as being the source for that backup. A little bit higher, yeah, there we go. So that's where it's actually dumping it. And here's the node, database 01 is where it's creating that backup. And it's going to rsync that over to our new node through Backup Ninja. So this is a MySQL dump, and then rsync is moving the backup over to a shared file system that then can be picked up by that verification node. I think we're running a little behind schedule, so I might skip ahead a little bit here. Okay, so let's jump in the console of that upgrade node. Take a look at that directory that's been mounted. So we see backups for all kinds of nodes, but specifically what we want to look at for database 01 is backups of MySQL. So here we see we have backup 0. We have a SQL dump. And we can see each one of the component databases here. Okay, so let's jump back over to the Jenkins console output. So it looks like it's going to start here shortly. Yeah, here we go. So now it's going to be doing a bit of restore on that, creating the databases and then restoring those. And now at the bottom, you can actually see that it's actually deploying Keystone on that node. So it's doing the OpenStack deployment as well. So one of the things that it's doing here is that since it's deploying Ocata, one of the differences is going to be you're going to have an extra database, or I'm sorry, an extra API endpoint for node replacement API, and you can see that that new endpoint is being created here. So yeah, we're logging back into that upgrade node and verifying that that the OpenStack packages are being installed. And just take a look at that. And we can also see those endpoints being created right in the console output. Okay, so at this point, what's happened is OpenStack's been deployed. The database has been backed up and restored, and the DB sync's been done to Ocata, and it's basically dumping an output of things like Keystone, service list and image glance list of images and Nova flavors and what Nova services are up and what volumes are there, you know, what heat stack or what heat services are there. So we're basically dumping all of that right to the console output, and if you see anything out of the ordinary, you can actually just look at it here instead of having to log into the verification machine to look at it. Let's do one other thing before moving on from this, though. We're going to check the API version on the actual node for Nova, for example. Okay, so we saw that on our live production system, we're running Mitaka at 13.1, and we're running Ocata here at version 15 of the Nova API. So now it wants to know the Jenkins pipeline wants to know if we want to proceed with the actual live upgrade to the target environment. So what this is going to do, you see virt destroy here. What this function is doing is it's going out and destroying all of the virtual machines that are acting as OpenStack controllers and proxy nodes. We would want to, again, if we wanted to do this in parallel, we would basically slightly modify this particular pipeline to do that, right? We would just keep both online at the same time and then have a shorter window where we're doing the database dump and restore. So let's log into I think we can actually log into a new, no, okay, so at this point we've seen that the controller node that was hosted by KVM02, which would have been CTL02, has been deleted, so we just showed that. And at this point we're almost ready to start. Yeah, at this point we're actually enforcing assault.control, which this is going to trigger new VMs being created for the new control plane and proxy nodes. So not there yet. Let's wait for some more output out of this. Okay, so now it's giving output. It's basically created those virtual machines. We should be able to flip back over to KVM02, take a look at its virtual machines, and we should see a CTL in a second. Yep, there it is. CTL02 is there. So our new control plane virtual machine has been created. So some of the things that have been happening for the last couple of minutes, all of the disks, the virtual disks for the Mitaka-based control plane were backed up prior to those VMs being destroyed, and the database has been backed up again for this portion of the upgrade, and that captures any kind of delta between when we did our verification test and when we're kicking off the real upgrade. Okay, so looks like at this point our new control plane is online. We fast forwarded a bit here, guys, because this took about between 30 and 40 minutes. I think we looked at the timestamps. I think it's somewhere around 42 actually for this one, from when we clicked proceed to when we just got that result. We can see that all these services, similar to how we saw in the verification step, we're seeing that these services are available. We're seeing the output of all the same OpenStack commands that we looked at earlier. And still, those same 3 instances are active. So again, no data plane outage incurred by doing this. Those VMs are still there. They're still passing traffic. So at this point, we should have a Ocata-based control plane and a Mitaka-based data plane. Again, meaning compute nodes are still running the Mitaka-based node compute services. Network nodes are still running Mitaka-based Neutron agents. And now we should be at a point now where you'd be able to go out and try to schedule your compute node upgrades and do those in batches all at once or one by one, however it needs to be done. So let's take a look at a couple of things. Let's do something. Let's create a new instance just to make sure we can do that here in a second. Taking a look at existing instances, take a look at existing networks. Okay, so now let's put a new image, or a new instance rather, just to verify that the Mitaka data plane and the Ocata control plane are working together, and we can still provision on OpenStack objects. Okay, so that instance was created. Let's just take a look. Okay, all right, there's our Ocata instance, and it is running. So we now have an Ocata-based control plane. Excellent. There's going to be more validation steps involved, and maybe test harnesses that you'll use post-upgrade. But this is the real upgrade portion of that pipeline. Right. Nick, did you have something? Actually, we're not quite done. We have the rollback that we can demo, but
okay. Well, we've got 7 minutes, so
yeah. Why don't we do Q&A while the rollback demo goes?
I think that's a good idea. So why don't you explain what the rollback is, start it, and then I'll ask you questions.
Yeah, sure. So let's skip to that real quick. Okay, so rollback is basically that we're going to power off the new controller and proxy nodes that we just provisioned. We're going to restore the disk backups that we made of those controller and proxy nodes, restore the database to its prior schema, and bring the controllers and proxies back online. It's going to actually ask you for double approval on rollback because it doesn't want you to make a mistake and roll it back if you don't intend to. And then it's going to go about restoring those disks. At the end of this recording, we'll take a look at the dashboard for this job, and it'll show kind of how long each stage took. But while that goes, why don't we go ahead and kick off the Q&A?
Okay, so let's start here. Are OpenStack and Kubernetes deployed in containers?
No. Actually, OpenStack is at this point a virtual control plane for us, and we're using virtual machines as a kind of the atomic unit where we can destroy and recreate them on demand. And again, configuration, while configuration does live with these services, it's actually defined elsewhere and generated and applied to these nodes. So we can treat basically any node in this cloud as pretty much disposable. So we have kind of a similar way of treating VMs to how you would treat a container in terms of its being disposable and all that, but and being kind of decomposed infrastructure, but it's not running on containers.
All right, and that was basically going to be the question. So if I'm understanding correctly, DriveTrain doesn't really care whether it's a container or a VM. It's all in the solve formulas that DriveTrain is running, correct?
Yes, so it'd be a mixture actually. So you'd probably have different steps in the Groovy script portion of how you're actually defining these pipelines, but those steps would correspond directly with how you would be doing things from a Salt perspective. So since Salt is basically the low-level execution logic here, doing the actual file managed and service restarts and package installs and all those kinds of typical configuration management functions. Those are going to be slightly different with a container-based system. We have done, again, prototypes and demos of a container-based control plane of OpenStack, but kind of what we arrived at was that we were able to kind of get a lot of the same benefits, indeed actually pretty much all of the same benefits that we were trying to achieve with containers through a virtual control plane with a lot less effort.
Got it. All right. So let's see here. Does DriveTrain also do lifecycle management for the new Mirantis containers as a service?
Yes.
Okay, that was easy.
Yep.
All right. So is DriveTrain a product that Mirantis sells? What does it take to reuse it in another environment? Only metadata changes?
Yeah, so that question could mean a couple things. One is that I could interpret that as meaning your goal is to have multi-cloud, basically a multi-cloud management plane. I look at DriveTrain as a management plane. So if I have a multi-cloud management plane, yes, DriveTrain is exactly that. If your goal is to just use DriveTrain but not use OpenStack, like you want to use this DevOps toolchain that we built in DriveTrain that's all packaged and integrated, if we want to reuse that for, let's say, some other application, absolutely you can do that, and you can reuse all the Salt formulas that we've written for components that overlap. But we're not going to have necessarily system level metadata and kind of a whole model built around every application that's out there, right? Like our focus right now has been on the two platforms I mentioned, Kubernetes and OpenStack, and we've also done a whole bunch of containerized workload type of orchestration around data analytics tools and processing components. Like I'll give an example: Kafka, Cassandra, HDFS, and Spark, right? Having all of those is consumable through DriveTrain. That's something we've done.
Okay. All right.
Completely outside the context of OpenStack, they can be deployed on OpenStack, and that can be done through DriveTrain, or they can be deployed on bare metal or as containers. And depending on how we've kind of engineered that, that's how it'll work. Okay, so
we are at time. We are at time, and yes, your demo did finish. So I do want to remind everybody before I forget that there is a PDF with more information in the handout section of the pane here if you want to see it. I'll give you 30 seconds to talk about your demo, and then we're going to have to say goodbye to everyone.
Okay.
Do you need your 30 seconds?
Yeah, I mean, I'll just take a look at this. So this is the stage view of the pipeline that we just ran with all three of those processes ticked. We did basically a small verification step to make sure that our changes were not going to break APIs and that our database syncs would work correctly to change the schemas. We did the actual upgrade, which you can see here took 42 minutes. We have a misreport on the rollback upgrade. It did not take 13 milliseconds. It actually took about 8 or 9 minutes. We could look at the console output and the timestamps therein and come up with the actual number. But there was a bug when this recording was taken, where it was reporting incorrectly on the amount of time taken. In closing, I guess I would just say, reach out to us if you have any other questions or interest, and we'll make sure those get answered, right, Nick?
All right, wonderful. Well, thank you all very much. I want to thank Ryan Day for joining us today, and I want to thank our fantastic back-end support, Michelle Yakura, for helping out here. We could not do this without her. And we want to thank all of you for taking your time to be with us today. And again, if you have any questions or any things that you would love to hear us talk about, please let us know. Okay, thank you all very much. Have a wonderful day.